Yeah, so you are basically substituting the coordinates of C, which is 3, 10, into the equation of, I'll call this 1, into 1, which means that we will get C equal to 1, and therefore sub C goes to 1 into equation 1, and we obtain the following: y equal 3x plus 1. Okay, that is equation of line CQ. Let's just call this 2. Then you know this is negative 1/3 because of the perpendicular, negative, the perpendicular rule, right? The gradient is the negative reciprocal of its perpendicular. Okay, so that means that you can now have another constant here. Let's just call this K. Okay. What else do we know? We know that this perpendicular line, it must, by our designer, must pass through the point P. Is that okay?
Okay.
Let me draw a few triangle P's for you. So if this was triangle CQP, we are trying to obtain this equation or this line. Can you see that line? Okay.
Yeah.
If alternatively, if this is our triangle CQP, we are trying to obtain this line, perpendicular to the line CQ, but also passes through the point P. I didn't label that point P. I don't know. Okay, never mind. You get the idea. Or alternatively, it could be this triangle CQP. We're trying to obtain a perpendicular line perpendicular to CQ, but also passes through point P3, which is this line here, line D. Okay, and then it just keeps going lah. Basically, in general, any generic P. How do we capture this idea of any generic P? We need to give a name to the coordinates of this P. Instead of P1, P2, P3, P4, let me just erase all those points. Okay. Yeah, I don't need so many, just a few for demonstration only. What I can do is I can label it as A, 0, where A can be positive or negative. Is that okay?
Hello.
Hello, mic test. Can you hear me?
Yeah.
Can do you catch what I said?
No. And now the screen is like black. Okay, now mine is back. It's back.
Okay. What? Okay.
I heard what you said about the perpendicular height.
Yeah, all these are the perpendicular heights. Okay. If for the different P, we are trying to construct equation of the equation of a perpendicular to CQ that also passes through the point P. Then the point P, if all these possible points, right, we want to capture all the possibilities. So what we need to do now is to give a actual identity. Sorry, I mean, you need to figure out what's the X and what's the Y in the coordinates of P. Definitely the Y is 0, right? Because it lies on the X-axis. P is a point on the X-axis.
Yeah.
Okay. Then after that, the X coordinate is the one that we don't know, question mark. So let's just give it a name. Let's call it A. A is positive or A is negative? Is that okay?
Yeah.
Can, good. So that means that we're just going to let the coordinates, LET, sorry if my handwriting, coordinates of P be P A, 0. Okay, where A is less than 0 or A is more than 0. I already explained just now, A cannot be equal to 0. Triangle does not exist. DNE means does not exist. Okay, good. So now we can proceed. How do you find the equation of this perpendicular that passes through the point P? Yeah. Maybe I make a small note here. Pass through point P, which is A, 0. What do you want to do with this point P?
Sub.
Okay. No, A, 0 into, maybe I'll call this star, into star. All right. Then we get what? 0 equals negative 1/3 P plus K. Now we want to solve for K. So that means that K is 1/3 of P. Is this clear? Then once we have the k, we can sub this k back in to star, back into star, which means that we will obtain y equals to negative 1/3 x plus 1/3 p. Is that okay? Can good. This is equation, I don't know. Can I just call this 3? Okay, I'll call it 3. So therefore, we have line CQ and line perpendicular. What we want to do now is to find the intersection between them, and then we calculate. Let's just call the intersection point R. Let R be the point of intersection between LCQ and L perpendicular. So how do we solve this? Solve for this coordinates of R. Equate 2 to 3. All right, so we'll end up with 3x plus 1 equals to negative 1/3 x plus 1/3 p. Now remember that x is what we are trying to solve for, and p is just a constant, just some constant. We're trying to solve for p eventually, but not yet. Here we can solve for x, so that we can get the x coordinate of this point R. So what do we get? 3 plus 1/3, that will be 10/3. And 1 bring over, you get 1/3 p minus 1. And x must be 3/10 of 1/3 p minus 1. Can? Which will give you p over 10 minus 3 over 10. Okay, good. Maybe I simplify a bit more. P minus 3 all divided by 10. That's the x coordinate of R. Then what's the y coordinate?
Sub x into 3.
Yes. 2 also okay. Let's just do that. Actually, would it be easier if you use 2? I think it's easier if we use 2. 3x plus 9. Okay, so let's use 2 instead. So we get y equals to 3x plus 1. Y equals to 3x plus 1. Copy paste the x. So we get p minus 3 over 10 in the blank space. Simplify, we get 3p minus 9 over 10 plus 10 over 10, which is 3p plus 1 over 10. Therefore, conclusion is coordinates of R is p minus 3 over 10, 3p plus 1 over 10. Are we done? No, we haven't solved for p yet. Okay, we found R. So let's draw a picture. So what we currently have is point C, I can't remember the name, point C, point Q, and a point P. And a point P here. Then what we have just found is the equation of the perpendicular. Not bisector, just perpendicular. And we also found the coordinates of this R here. Right? R is this guy. And P is what? P is, how come I have P? Wait a minute, let me think a bit. Oh my goodness, what am I doing? Sorry. The coordinates of point capital P is a comma 0, but I sub in a little p here. Wrong, should be a. Okay, I'll try to, I'll just change it to a. Okay, a. Oh no, wait a minute. Let me change all the p's to a's. Oh no. Sorry, for the confusion. I hope you are not too confused. X coordinate of the capital point P is little a comma 0. Then the coordinates of the point R is a minus 3 over 10 comma 3a plus 1 not comma 10 over 10. Okay, a minus 3 over 10, 3a plus 1 over 10. Now we have the coordinates of R and P. What can we do? We know that this must be the what of the triangle?
No.
CQP. The what of the triangle?
The height.
The height of the triangle, which we already found out to be square root 10. So that means we can use the distance formula to find out the height. Correct or not? Oh, so and then we equate to square root 10. Wow, not enough. Add another page. Okay, let me know if you can find a faster way. I cannot think of a faster way right now. So RP is very simple. You just need to find the distance. X minus x squared plus y minus y squared. Now, in that case, it will be a minus 3 over 10 minus a. Then 3a plus 1 over 10 minus 0. Right? Okay, then we want to equate this to, this is just the height. Perpendicular, which is square root 10. Can? Good. Now we can solve. So I noticed that square root on both sides, right? Square root of whatever equals square root of whatever. So just square both sides. I mean, square throughout the entire thing to make sure they stay equal. Then after you square a square root, they cancel away. I'll just copy and paste its insides. Remove the square root. Equals to 10. This one, of course, you can simplify a bit. Then, yeah, let's just continue and expand this. Wow, this is 10a over 10. So it becomes minus 9a minus 3 over 10. Bracket square plus the other guy minus 0. So it's just 3a plus 1 over 10 bracket square equals to 10. Is that okay? Continue. Then now we try to solve for a. How do we do that? Let me convince you. Negative x squared is actually negative 1 squared times x squared. So it's just x squared, right? I can times negative 1 to the inside. So minus 9a minus 3, I can change it into positive 9a positive 3 over 10 bracket square. But wait, 9 and 3, I can factor out of 3. Then I'm left with 3 times 3a plus 1. Then when I try to square, I'll get this square, this square, this square, which means that I will now simplify it all into 9 times 3a plus 1, 3 squared. I mean, okay, I show a bit more working. 3 square times 3a plus 1 bracket square over 10 square. Is that okay? Can, good. Then you simplify, you end up with 9 over 100 multiplied by 3a plus 1 bracket square. Maybe I'll leave it alone first. Why? Because I see a pattern. Here, 3a plus 1 bracket square. Sorry, I mean 3a plus 1 over 10 bracket square. It's really just the same as 3a plus 1 bracket square, then over 10 square. Correct? Yes?
Yeah.
10 square is what?
100.
So over 100, a. This guy is also, this guy 3a plus 1 square, that guy also 3a plus 1 square. Lucky I never expand. Then I can see straight away. 9 over 100 plus 1 over 100. That gives me 10 out of 100 of 3a plus 1 bracket square. Can you see that? Then after that, you can cancel away a 0, 1 over 10, bring that over, you get 3a plus 1 bracket square equals to 10 times 10, which is 100. So 3a plus 1 must be plus minus 10. So there are 2 possible values already. That's why the question started by telling you 2 possible coordinates. Let's split it up. Right? Then solve for a. Minus 1 divided by 3. Minus 1 divided by 3. This will give you a equal to 3 or a equals to negative 3 and 2/3. Yeah. All right. Therefore, conclusion is P must be negative 3 2/3 comma 0 or P must be 3 comma 0. Is that clear?
Yeah.
Okay. Then that's how they get the 2 solutions. I guess there's probably a more efficient way to do it because this is only 3 marks. I don't know lah, or is it just because it's Raffles? Yeah. Okay.
Yeah.
Yeah. It's just very long-winded, but I hope you get what's going on. Okay. Next one. This one, you need to know the rectangle property. Diagonals bisect each other. Right? So what do you know about MB and MA?
Isosceles.
More importantly, their lengths are equal. Okay, so you can use distance formula for each of them. But in order to solve for m, you need to have a comma 0, just like the previous question, okay? Okay, then you just find the length of AM, find the length of BM, solve for A. Let's just do it. Let's just do it. Yeah. So I should use red pen. Let M be A comma 0. So since diagonals of a rectangle bisect each other, this is just a rectangle property. It implies that MB equals to MA, or BM equals to AM, same thing. So that means we can find the length of MB and MA. Let me copy down the coordinates of A first, as well as B. So I don't need to keep scrolling around. Yeah, so now we can find the length of MB. Square root of, what is it? A minus, or negative 2 minus A, bracket square, plus 6 minus 0 square. That's the length of MB equals to length of MA. So minus 1 minus A square plus 3 minus 0 bracket square root. Is that okay? Very good. Square both sides. They cancel away with the square root. Then expand. So minus 2 minus A is actually the same as 2 plus A bracket square, right? So you expand it. No choice, I have to expand. I don't see any common factors. So A square plus 2A, 4A plus 2 square, 4, plus 6 square, 36. Equals to, this guy minus 1 minus A is actually plus 1 plus A, bracket square, which is A square plus 2A plus 1. Then plus 3 square, so it's plus 9. Is that okay? Continue simplifying. Luckily for us, A square on both sides can cancel away. Then you're left with 4A minus 2A equals to 1 plus 9 minus 4 minus 36. Okay? Then you're left with 2A equals to 1 plus 9 is 10, 10 minus 4 is 6, 6 minus 36, negative 30. Negative 30. So A equals to negative 15. Is it shown? What did they ask for? I can't remember. Yes, negative 15. Okay, then therefore M is negative 15 in comma 0, shown. Okay? Okay, good. Moving on. So part 3, find the equation of the circle passing through ABCD. So what you need to realize is that because they bisect each other, all these lengths are equal. Doesn't that just look like a radius of a circle?
Yeah.
And M is the center, lor. So find the equation. How?
Wait, okay. X plus 15 square plus Y square. Wait, no need bracket. Oh.
Yeah.
No
Then
need
equals
bracket. Equals to, I mean, you have the point A and the point M. So then you can find the length of the radius, then square it.
Very good, exactly, that's all. Don't need show, you do on your own.
Yeah, don't need.
Okay, can you get 205 R square. Okay, next one, I haven't checked yet, sorry. Do you know what are the questions you got wrong? Have you checked the answer?
I'm not sure.
Okay. If you get the right answer, I'm just gonna mark it right and move on.
Yeah, okay.
No, okay. 10 and 3 halves, yeah, 6 1/4. Yes. X minus 7 brackets square plus y minus 5.5 bracket square. Okay, equals 25. Okay, good. Next one. What is this? Minus 1/2, 3 halves. Okay, radius square root 22 over 2. Good. Next one. Wow, that's a complicated looking diagram. Y minus 2x plus 18. Okay. 5 1/5. Yeah, correct. And 7 3/5. 7 times 5, 35. 38 minus 35 is 3. Okay, good. Yes, 18, 14, good. 24, 10, 112. Okay. Very good. Then continue. X minus 7 bracket square plus y minus 4 bracket square. Square root 55 square. Okay. And 7 comma 4 square root 55. Can question 11, not sure. Okay. Help me to remember question 11. I will come back to it. Okay, question 11. Mic test, can you hear me?
Yep.
Okay. Question 11 later. Remind me to go back. Okay. And 36 square feet. Wait. Where is this? 36. Square units. Then a square root 9 root 5. This one. Let me see. What is this number at the bottom? 1445 over what? What's that number? Hello.
Hello,
I cannot hear.
I think it's a 9.
Oh, it's a 9. Then it's
I
wrong.
think, yeah.
Let me see. Bracket square plus negative 1 plus 3. Bracket square. 1445 over 9. Okay, so something is wrong. Let me double check first. Yeah, because it doesn't match up with the answer. Okay, then the perpendicular. What is this? Okay, let me read the whole question. Okay, so you want to find this guy. Okay. Maybe your coordinates of f is wrong. Okay. Equation of BD, equation of AC. You need to take line AC, intersect with line, what is it? BF. But how do you find line BF? It's perpendicular, passes through the point B. If you go to AC, passes through the point B. Okay, then in that case, what is the gradient of AC? Gradient of AC is -half. So you just take negative reciprocal. That will be the gradient of BF, which is flip it around positive 2. Okay, then you end up with a positive 2x gradient and pass through the point. So y minus -1 over x minus 1 equals to 2 is the equation of the line BF, right? Simplify, we get y plus 1 equals 2x minus 2. So y equals to 2x minus 3. Okay, that's good. Do you get that? Y equal to x minus 3? You did, Okay. Sub 1, what's 1 into 3? Let me see, where's your 1? It's AC. Okay, correct. So that means must be some algebra mistake already, because your concept is fine. This is correct. Okay, let's take a look. -half x, what happened there? How do you copy wrongly? -half x plus 4 and 2x minus 3. Okay, this is fine. Times 2. Oh no, minus x bring over become plus x. It's not 3, it's 5.
Oh, okay.
Minus 6 bring over become plus 6. So 8 plus 6, which is positive 14. So 5x equal to 14. X equal to 14 over 5.
Okay,
yeah.
I keep
And
on doing that.
Error carry forward. Just do it slowly, huh? Okay. No, never mind.
Okay.
I'll just mark a cross for you. Go and figure out what's wrong. Okay. Redo. Error carry forward all the way. Yeah. Up to the tick is correct lah. Then just do your correction. Okay. Moving on. I'm not gonna go through the rest. So let's see. I mean, I'm not gonna go through the rest of question 12. Okay, 2/2 is fine. 3/4 x. Oh, what's wrong? Find the equation of the tangent to the circle at the point 4, 2. Okay, you just need to identify where is 4, 2. Is it on the circle? Does it lie on the circle? Let's verify first. Sub x equal to 4, y equals to 2. Into, let's call this equation. Oh, I cannot use black. I have to use a different color. Sub into equation 1. Then we check the LHS. This will be 4 minus 2.5. Yeah, never mind lah. Just copy word for word and then just use a calculator. Whatever is the number. 4 minus 2.5 bracket square plus 2 minus 4 square. You get 25 over 4. Then is it the same as the RHS? Yes. So this implies that the point 4, 2 does lie on the line. I mean, on the circumference of the circle. Okay, so if it lies on the circumference of the circle, it means that there must be a radius here. Yeah. How come your perpendicular never pass through the center?
Oh, yeah, okay.
Yeah, but okay, it should, right? Yes.
Yeah.
Okay, but should pass through the center. So that means circle, tangent here, then you have a perpendicular radius. All right, good. What did they ask? Find the equation of the tangent to the circle at a point 4, 2. Equation of the tangent at point 4, 2 of the circle. So basically it's a perpendicular line. So if you know the gradient of the radius, you know the gradient of the line. You have a point as well. You have gradient, you have point, you can use point slope formula, find the equation. Done. How do you find the equation of the radius, or at least the gradient? Don't need equation, just gradient of this radius.
You can use 4 minus 2 over 2.5 minus 4.
Correct, yes, very good. So let's just call it M. How do I even describe this? Let's call it C for center. Okay, let's call it O for center. That's origin. Let's just call it P. P for the center. Then this point of intersection, let's call it Q. So gradient of PQ must be whatever you said. Yes, y minus y over x minus x. What's this equal to? Negative 1.5, which is 4 over negative 3. All right, then that means that the gradient of the tangent line must be, what is it?
Is 3 over 4.
Positive 3 over 4. Well done. Then that means that we can find the, and this tangent line also passes through, tangent passes through 4, 2. Do I need to continue?
Use point slope formula.
Equation of the tangent, yes.
Wait, what they want? Wait, what they want? I
equation of the tangent, which is point slope formula. Okay, go back.
Oh.
Right, that's all.
Yeah, okay. Yeah, then, okay.
Yeah, I'll just fill in, then you can simplify the rest, Okay. Okay. Moving on. Yes, the question just now, what was it? 11, is it?
11.
Okay, let's take a look. So no solution by accurate drawing. The diagram, which is not drawn to scale, shows a triangle A, B, C, where A is -4, -6, B is -7, H, C is 2, 6. Now, given that AB equal to BC, and so you get an isosceles triangle here. D is a point on x-axis such that AD is parallel to BC, and that P is a point on AC such that the area of triangle ABP is 1/3 of the area of triangle ABC. I thought I answered this question. Like you were asking me. It looks very familiar. Okay, basically, right, whenever they have this kind of drawing, you must notice straight away, oh, they share the same what? The two triangles.
Height.
Perpendicular height. So that means the ratio of the area is the same as the ratio of
the base.
Correct. The length of the bases, the ratio of the length of the bases. So that means, let me just write it down. What is it? Area triangle ABP over area triangle ABC is 1/3. It is equivalent to the ratio of the bases that share the same perpendicular height. So ABP is what? AP as the base. And ABC must be the entire length AC equals 1/3. Is that okay? Ratio of the area is ratio of the bases, provided they share the same perpendicular height. So that means that you have a ratio 1:3. Then what do you want to use now? 3 units, 1 unit.
Length of line.
No. V for
vector.
Exactly, vector.
Okay.
Same thing, okay. They're just trying to I don't know why they could put the extra layer. I gotta hand it to RP. They don't want to tell you directly it's ratio 1:3. They must tell you indirectly. Anyways, you know how to do this. But I just go through What's the total length here? -4 to 2.
6.
6 units.
12.
Here is 1/3, so it must be 1/3 as well. 4 units total. That means what doing 12?
The A to C, the Y.
Correct. Yes. Good. Then that means that we now have 4 units. This represents 4 units in the vertical length. That represents 4 units in the horizontal length. Here, the green length here is just 1 unit, right? 1:3. So that means that we just want to have it's blocking the words. A bit difficult to read. Something like this. That is worth 4 units. So it means that
divide by 4 times 1. Or actually just 6 divided by 4.
Yeah, just 6 divided by 4. Then you add on to -4. So therefore, the coordinates of Q will be -4 plus 6 divided by 4 times 1, if you want to really use the ratio. And comma, the y coordinate -6, add on something. How much? This blue length, which is 1 out of 4 of 12 units. So 12/4 and times 1. Okay, can So let's say I give you an extra bonus question. Let's say that I gave you, I don't know, maybe I'll squeeze it over in this blank space. You got a point A here, which is -2, -1. We have a point here that's 58, 119. I tell you that, I don't know, let's just call it A and B. I have a point here. Then the ratio is, let's see, 3:4. Find the point Q.
Well, from here to here is 4 units.
4 units. From B to Q is 4 units. The A to Q is 3 units. Or in other words, AQ is to QB ratio is 3:4. Good.
So then from here to here will be -2 plus 60 divided by 7 times 3. And then for the y will be -1 plus 120 divided by 7 times 3.
Right, correct. Yes, yes, very good. Okay, you got it already. Yeah, okay. You can do that again later on your own. Okay, so yeah, then you simplify this down. I believe you'll get the coordinates of, that is not Q, sorry, that's P. Right, the P is here, sorry. Oh, can good. How about point D? Did we find point D already? Not really, yeah. Okay, actually, let's just answer the question first. I'll continue reading the rest of the question. AB equals to BC, D is a point on x-axis. AD parallel BC, can't remember the question already. AD parallel BC. P is a point on AC, so that you have that ratio of the area. Line BP, this whole line, meets the line AD at Q over here. Okay, then show that the value of H is 3. What's H? Where's H? Oh, here, B is 7, comma H. Show that H is 3. How do you do that? Equal length, so
or AB equal BC.
yes. Okay, let's do that. Let's find AB first, step by step. So I read AB square. So you can get rid of the square root. So that will be x minus x. I think that's just a 3 square plus y minus y. That's just a h minus minus 6 square. How did I get a 3? -7, -4. The difference is 3. Okay. Square it, then the negative doesn't matter. Simplify, you get 9 plus what is this? H plus 6 bracket square. I think I don't want to square it because I'm lazy. I don't want to square it. I will deal with it later. Then let's look at the other length, which is BC square. BC square. So it means you have x minus x. So that's a 9 square plus y minus y. So h minus 6 bracket square. 9 square is 81 plus h minus 6 bracket square. No choice. Here you got h plus, here h minus. They are not the same. If you try to combine them, you may get a square minus b square format, but there's no point to doing it. Basically, you know these AB equal to BC, so AB square also equals to BC square. Then you can equate them. Do you know why I put square here? Why I don't find the length? Because I know at the end of the day I'll have a square root. Then I'm lazy. I don't want to write square root. Okay, can okay, yes, I'm lazy. I don't want to write square root. That's why. Okay, that's all. Anyways, you're still gonna get rid of the square root at the end of the day, once you equate the length. So might as well not write it at the first place. Write a new letter 2 there, easier. So 9 plus h square plus 2 times h times 6, which is 12h plus 36. 81 plus h square minus 12h plus 36. Is this part okay? Good. Simplify. Coincidentally, h square cancels away. 12h minus 12h, do they cancel?
Yeah, no.
No, be careful. Here the minus is not on, plus and minus not on the same side. Bring over, it actually becomes 24h. Okay, good. How about 36 and 36? Do they cancel?
Yeah.
Yes, very good. Then after that, you are left with 81. 9 bring over minus 9. Did I miss anything? Hopefully not. Let me know if I have. 72. Therefore, h equal to 3. Divide by 24. Can?
Okay.
Okay, very good. Now, shown. So now that is part 1. Part 2, let's show that the angle ABC is 90 degrees. Where's ABC? Over here. How to show it's 90 degrees? Gradient.
Equal times equal minus 1.
Very good. Very fast. Okay. So MA, let's draw a line. Part 2, just now was part 1. Part 2, MAB. We already know the coordinates. I'll just write down the coordinates first. A is -4, -6. B is -7, H. Then C is 2, 6. We want to find MAB and MBC. Then show that the product equal -1. Okay, then I'll just write down the formula first. What we expect. Write down a template. Okay, then now we fill in the blank. So how to find MAB? Y minus Y, X minus X. -6 minus H over -4 minus -7. Simplify, you get -6 minus H. Oh, sorry, I already know H. Sorry. Just replace it with 3 straight away. And just use a calculator. -9 divided by -4 plus 7, you get -3. Is that okay? MAB? Very good. Now we need to show MBC is positive 1/3. MBC is what? Y minus Y over X minus X. Is this positive 1/3?
Yeah.
Very good. Then now just for the sake of completion, we just show it's -3 times positive 1/3, which ends up being -1. And we are done. Okay, I'll just write down the conclusion now. Therefore, AB is perpendicular to BC. Draw a square box. Square box means you are done. Proven. QED. Shown. This is bracket shown. I don't need a square box. Or you can shade in the square box. Doesn't matter. Okay, now part 3. Find the coordinates of D and of P.
Okay, I mean P is found.
P is found. Okay, very good. How about D?
Yeah, how about D? Y-axis is 0.
Hold on. Did I think my P might be wrong. Is it? It's wrong. Sorry. Oh, no. This is not 3.
It's 2.
Should be 2. Sorry. Yes, because ABC is the entire length. So it's AP, that's 1 unit, AC, that's 3 units. So we are not interested in AC, the entire thing. We are only interested in PC, which is 3 minus 1, 2 units. Sorry. Yeah. So here we do again. What would it be? -4 plus for coordinates of P.
6 divided by 3 times. 6 divided by 3.
Correct. Should be 3. This one, let me calculate again. 3 unit. 6 divided by 3, that's all. Times 1. Then the other one guy, -6 plus
12 divided by 3.
Okay, very good. Then you will get the correct answer of -2, -2. Makes more sense. Okay, let's look at the coordinates of D now. So how? Yes, you identified Y coordinate should be 0. How about the X? I noticed parallel lines. We haven't used that information. Might be useful.
Find you find
H
gradient BC, then gradient AD equal gradient BC, then you do point slope with point A with your gradient of AD, then you sub Y equals 0 into that.
Don't need sub Y equals 0. Don't need. Let me show you. MBC is what again? We calculated already. 1/3. 1/3. Yes, we can recycle. Very nice. So part 3, I'll just write it here. Part 3, we found out MBC is the 1/3. So that means that the gradient of AD is also 1/3. This is because parallel. BC parallel AD. Therefore, we get how do you find the gradient of AD now? Which is 1/3. Y minus Y, 0 minus -6. X minus X. Let's just call the X coordinate A. So A minus away -4. Is that okay?
Yeah.
From there, you can cross multiply. Okay, we simplify it a bit first. Yeah, then you can solve for A already. And you are essentially done. 3 times 6 is 18. And therefore A is 14. So D is 14, 0. Is that okay? Yeah. Cross multiply. Okay, good. Point D is found. Moving on. Part 4. The point G is such that ABCG is a square. Where's ABCG? ABC is here. Where's G? Must be here, right? Can see the square? Okay, very good. So we want to find this point G. Let's just mark a point like that. What's the coordinates of G? Okay, I need to change color. G question mark, comma, question mark. How? This looks very familiar. Feel like we did this before. But for a different shape. How?
A vector.
Yes, vector. So opposite sides of a square are equal and parallel. So here and here. Can see?
Oh.
Okay, good. So let's use gray color. Yeah. Gray and orange. Gray and orange. Okay, good. Yeah, my gray a bit too low. Let me try again. Yeah, close enough. Okay, therefore we can calculate the length. What is this length here?
9.
Good. What's the other length?
3.
3. Correct. Okay, then of course it must be 9, 3 as well. Sorry, it's getting quite messy. I hope you're still
5 minus 3.
We are 5 minus 3.
No, like the x coordinate and the y coordinate of G.
Correct. Very good. Yes. The 2 add on a 3, the 6 minus or 9. Okay. Can? Yeah, over here lah, huh? Maybe I'll just show some working. 2 add on a 3. This guy is 6. Subtract a 9. That's how you get your 5, negative 3. All right. Good. Next, part 5. Yeah, part 5. Find the area of triangle ABC. If you want point slope, the shoelace formula. Do I need to show you?
No.
No, skip, try on your own. Good. You can do already. You have shown me many times you can do. Let me just write it down for you. Shoelace. Okay. Down, product, minus away, up, product. Take the modulus times half in front. Okay, can. What's the next question? Go. Question 15. Okay, good. Let's take a look. Solution of equation by accurate drawing not accepted. Okay, I'm just gonna check your answer only. If you get it right, I'm just gonna move on. Part 2 is 0,9. Yes, part 3 is 2 half. Wait. Or 1 half. Correct. Your answer is fine. Part 4 is 10 units. Okay. 16 is okay. Something wrong. Let's take a look. So point P is the point 5, -2. Line joining the points P and Q is parallel to the line 2x plus 3y equal to 0. Perpendicular bisector of PQ passes through the point 4, 3. Find the equation of PQ, equation of the perpendicular bisector of PQ, and the equation perpendicular distance from 4, 3 to the line PQ. Now I cannot understand by reading so quickly. I need to draw a diagram. Where's 5, -2? Maybe somewhere here, huh? Then parallel to line 2x plus 3y equal to 0. What was the gradient? Equation of PQ, -2/3 plus 4/3. So maybe something like that. Actually, where's Q?
Where's Q?
Oh, that's part D's answer. You haven't do part C, so part D also haven't do. Never mind, we don't know where is Q, but it's somewhere on the line, huh? This is 5, -2. Okay, I need more space. Maybe I'll use red color. No, I'll use blue color. Okay. Parallel to the line 2x plus 3y equal to 0. So this equation is y equal to negative 2/3x. So it's this guy, huh? Or equivalently y equal to negative 2/3x. Then pass through the origin now because y-intercept is 0 plus 0. Then equation of perpendicular bisector of PQ, you found it by, how did you do it? Gradient of PQ, 3/2, and it passes through the point 5 comma negative 2. 3 comma, no, 4 comma 3. Oh, okay. Passes through the point 4 comma 3. Okay. Can. Then you can get the gradient, you can get the equation of that line. Here is 3/2x, so it's positive 1.5 and passes through negative 3. So maybe somewhere like over here, something like that. This is negative 3. Huh? That is your perpendicular, what do you call this? Perpendicular bisector of PQ. So okay, maybe I shouldn't move my P a bit further away. Yeah. Can. Then if that is the perpendicular bisector, then that means that your Q must be somewhere here, huh? Actually, just to be more precise, I need to be more precise so I can know exactly where is Q. I don't want to be confused. So let's figure out where is the x-intercept of this perpendicular bisector. X-intercept means you sub y equal to 0. Then you solve 3/2x equals to positive 3, x equals to what's this? 2/3 times 3, which is 2. Okay, so it passes through 2 comma 0. If it's 2 comma 0, how about this fella here? The original equation here. What's the x-intercept? Let's figure this out. Also, we can draw a more accurate picture. Sub y equal to 0 to find x-intercept. You end up with 2/3 x equals 4/3. So x must be equal to 2. Oh, what a coincidence. We just found out that. What? What did we just find out?
X-intercept
of both lines are the
same.
That means on your diagram, you see these two intercepts very close, right? Shouldn't be very close. It should be exactly the same. So let's just move my diagram. Okay, you know what? I'll just move my point P and the line. Yeah, something like that. Let's just draw a more accurate picture. Okay, good. So now what? I don't know. Now what? I don't know. Let's look at part C. Perpendicular distance from the 4,3 to the line PQ. 4,3. Where is 4,3? It's a point that lies on the line, on the perpendicular bisector, right? So maybe it's somewhere here, huh? 4 must be to the left of B, to the left of 5, right? That's why I shifted it a bit more to the left. Okay, so 4,3 is over there. What do they want? They want perpendicular distance from 4,3 to the line PQ. So since this is perpendicular bisector, we know they pass through the same fixed point 2, 0. Where is your point Q now?
On the line PQ.
Can you mark out for me where is it? Draw on the graph. Yeah, somewhere there. Just need to make sure that the distance between them, these two are the same. And what else do you realize? What else do you realize about 2, 0? It's the what of the
midpoint.
Midpoint already, yeah. Very good, because it's perpendicular bisector. So that means you can find out the coordinates of this point Q using midpoint formula. Is that okay? Let's just call it I don't know, x, y. Not to be confused with the variables x and y. I'm just recycling the letters. So using midpoint formula, what can we deduce? M, which is 2, 0, is equal to, another way to phrase it, what would it be?
5 plus x divided by 2. And
the
then
y?
minus 2 plus y divided by 2.
Can also minus 2 plus y divided by 2. Exactly. So you can form two equations. 5 plus x over 2 is equal to 2. Solving for x times 2, you get 4. Minus 5, you get negative 1. Oh. Then here got minus 2 plus y. It's connected by an n. Minus 2 plus y equals over 2 equal to 0. Times 2, you get 0. Solve minus 2 bring over become plus 2. Therefore, you get the coordinates of q to be negative 1, 2. That's the coordinates of q. Does it answer the question? How come you circle part C? Perpendicular distance. Oh, right. I'm supposed to answer perpendicular distance. I ended up answering part D. Sorry. Perpendicular distance from 4, 3 to the line PQ. Okay, we already found out the midpoint there. So that just means we need to find the distance between M and 4, 3. Okay. Let's just give it a name. Let's call it point R. Also MR. Let R be 4, 3. Let. That means MR is what we want to find. Distance must be 4 minus 2 is 2 square, plus 3 minus 0 is just 3 square. Take a square root. Pythagoras theorem. 2 square is 4, 3 square is 9. 13. Answer. 4 plus 9 is 13. Square root 13. Is that okay? Can good. Then yeah, solve already. Any questions?
No.
No? Okay, good. Next. Part 2, find coordinates of E. Ratio question again. Let's read the question. So ABC is a right angled triangle. DE is parallel to BC. Coordinates of A, B, C are those 3 points respectively, and AB is thrice the length of DB. Remember how to prove similar triangles? Remember this? I'll just tell you. Basically, whenever you have two triangles, two angles, like let's say triangle here, 2 of the angles are the same. It means that they are similar. Okay. Left with left same, right with right same. That's it. Here, I hope you can tell that these two are similar triangles.
Okay.
Common angle here, then because of parallel lines and a straight line passing through them, by corresponding angles, we can know that they are angles. These two angles must be the same. So this guy and this guy are similar. This angle, same. That angle at the top is a common angle. So therefore, AA similarity test concludes that you can help us to conclude that, allow us to conclude that these two triangles are similar. And actually, this angle is 90 degrees as indicated by the square box. Okay, just to be more accurate, I should draw a square box. And it's a right angle, you can also, not important. Right angle, so what? Doesn't matter. AA similarity test, they are similar. Very good. Now that we know they are similar, and we also know that AB is 3 times the length of DB, AB is over here, 3 units. Then DB is 1 unit. That means 3 minus 1, you get 2 units. Exactly what you wrote here. Very good. Okay. So what? Find the equation of the line BC. You found that already. Okay, then part 2, find the coordinates of E. If you know this is 2:1, right? And it's similar triangle, you should also know that this to this will also be 2:1. Does it make sense?
Okay.
Accept. Good. So now we just write down the 2 there. Maybe I'll use square box. 1 there, square box. Okay, since we know there's a ratio, what method can we use?
Vector.
Exactly. So let's just draw in the vectors. Here, here, there. Okay. Find coordinates of E. Maybe we start with 0. Okay, I don't want 1 unit is smaller. Let's start with 8. Must minus away this purple length, right? What's the
Yep.
purple length?
Minus away 8 divided by 3.
Very good. And how about the Y coordinate? Plus or minus 2?
Plus 4 divided by 3.
Very good. Because difference between 6 and 2 is 4. Then there are 3 units here total. So you want 1 unit, then just divide by 3. Let's say I phrased it. Okay, never mind. It's the same thing. I wanted to ask you, what if I start off with 0,6? What do I need to plus? What do I need to minus? I think you know. You can go think about it. Okay, anyways, you get the same the answer here. 5 1/3 and 3 1/3. Use a calculator to simplify. Okay, next we want to find the length of AD. How? How do you find the length of AD?
You find D using vector.
Find D using vector. Can. Okay, let's do that. Maybe I'll erase all the details first. Okay, you already have the 2 1 there. I'll just keep it. Then how? Vectors. Here. Okay, I don't use the same color. Here vertical. There horizontal. Right? Good. What's D?
D will be
2:1 ratio also. Maybe you start this time with 0,6. Then we try to add or subtract. How do you go from 0 to this? You need a plus, right? Plus how much?
Plus 2 divided by 3.
But 2 divided by 3 will give you 2 unit plus 1 unit, 3 units. So that's only 1 unit. But this length here is not 1 unit, it's 2 units. So you need to times 2 exactly. Then how about the 6?
Minus 6 divided by 3 times 2.
Very good. Exactly. How about let's try now with the simpler case. I think you can start from B, easier. D is the coordinates of B, but you have to modify it. Go from 2, move to the left. So minus to the X. Minus how much?
Minus 2 divided by 3.
Exactly. Then the 0, go up.
Plus.
So plus
6 divided by 3.
6 divided by 3. Then you just have 1 unit. That's why you times 1, or you don't need to simplify. But you don't need to times 1, of course. You can go and check in a calculator. This should give you the same answer. I think so. Wait. Wait a minute. Yeah, it's the same answer. Okay. Can? Okay. Yeah, you can either go from the right to the left or go from the left to the right. Same thing, Just need to use ratio or vector method. Okay, Ken. That was point D. Why do we find point D? You want to find length AD, right? Then how? Mic test. How? How do you find length AD? You got A 0,6.
Find MAD and then point slope.
Wait. Length only. They only asking for length.
Then use length formula.
Exactly. Just use length formula. So 4/3 minus 0, x minus x, bracket square, plus y minus y, 6 minus 2, bracket square. By the way, do you know that the order doesn't matter? 4/3 minus 0 versus 0 minus 4/3.
Yeah.
6 minus 2 versus 2 minus 6, same thing. So there are 4 possible ways you can do it. Right? 4 possible ways. Do you get what I mean?
Yep.
It's like a red ball and a blue ball versus a green ball and an orange ball. You can move it around. Blue ball, red ball, orange ball, green ball. but there's a total of 4 possible ways. Huh? Red, blue, green, orange, or orange, green. Blue, red, green, orange, or blue, red again, but orange, green. Okay? 2 times 2 ways. 4 possible ways. Can I?
Yeah.
Okay, that was crash course on permutation combination. But never mind. You get the final answer. I believe you'll simplify into 4/3 times square root 10. Okay. Now for part 4, find the area of triangle ABC and hence find the length of the perpendicular distance from B to AC. How? Area of triangle ABC.
You can find AC.
AC? Wait. Area of triangle ABC first.
Oh, shoelace. What am I? Okay. Yeah, shoelace.
Actually, yeah. You can even use, since there's a 90, you can easily find length AB, find length BC, then half time base times height. I think that would be easier than shoelace. Okay. Let's do that. So AB will be what? I see that there's a rise 6, run 2, 6 square, 2 square. Then you just take a square root. 36 plus 4, that's square root 40. I can simplify it, but I don't want to. BC is what? BC is square root of. I see it goes from 2 to 8, so it's 6 square. I see it goes from 0 to 2, so it's plus 2 square. 6 square, 36, 2 square, 4, so square root of 40. What a coincidence, they're the same. Then therefore, we can calculate the area of the triangle ABC already. So area of triangle ABC, we half times root 40 times root 40 again, base times height. So you square it. It happens to cancel away the square root. You're left with half times 40, which means you're left with 20 units square. Is that okay? Can I think it's faster than using shoelace. Yeah. So how do you find the length of perpendicular distance from B to AC? What you were saying at first.
Find AC.
Find AC. So let's find the length of AC. What will it be? I see it goes from X to X is 8 units, so 8 square. I see it goes from Y to Y, 6 to 2, it's just a 4. So plus 4 square, take a square root. Doesn't matter whether it's positive or negative because square will make it positive. 8 square, 64, 4 square, 16. 64 plus 16 is 70 plus 10, which is 80. Square root 80. Then therefore, your area of the triangle is what? Half times AC, which is square root 80, times height. Let's just call it H. But we already know the area of the triangle is 20. So equate to 20. Is this part okay? Solve for H. Don't need shoelace. 90-degree triangle. So 20, half, bring over, become times 2, divide by square root 80. Can? Very good. Yeah, what's the answer? 2 root 5. Okay, let's just simplify it. 80 is like, what is it? For 16 times 5, right? So square root 16, square root 5, 4 root 5. 20 times 2 on top. This one can cancel away, become 1, 2. This one can cancel away, becomes 10, 1. So you're left with 10 over root 5. Rationalize, you multiply top and bottom by root 5. Which means you're left with 10 root 5 over 5. 10 over 5 is what? 2 root 5. Did I get it correct? Is it right? 2 root 5. Very good. Okay?
Okay.
Can? Good. That is 19. Okay, moving on. Wow, another one. Okay, can. What happened? Parallel to y-axis. What's y-axis? Vertical line, right? So that means the equation is just x equals something. What's the equation of the y-axis?
X equals 0.
Exactly. So here parallel to y-axis just means it's x equal to some constant. Maybe it passes through a certain point and you just need to take the x coordinate of the point and you'll get the equation of the line. Okay, let's read the question first. The coordinates of the points A, B, and C are blah, 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 respectively. Find the equation of the line AB. Find the gradient, point slope formula, get the equation. Done. Very good. Find the point P such that P lies on the line AB and CP is parallel to the y-axis. Wow. Let me visualize what's going on. AB. Oh, yeah, I need to draw the graph. 1,4 somewhere here. 3, oh, maybe a bit. No, should be somewhere here. Sorry, got the direction wrong. 1,4, then after that, 3, -2, so maybe somewhere here. Then -1, -3, -1, so it's somewhere to the left, but +3 units, so somewhere lower than 4. So that is point C, -1, -3. Okay, good. Now find the equation of the line AB. Okay, let's draw a line that passes through AB first. What about it? You want to find the equation. You found it already. Find the point P such that P lies on the line AB and CP is parallel to the y-axis. Hold on. That's a bit weird. Parallel. Oh, okay. Line AB is not referring to line segment AB. Please take note of the difference between line segment versus line. Line extends in both directions forever. In particular, it extends in this particular direction over here, such that here is a vertical line that is parallel to the y-axis, the green one. So where do you think it's P? Yes, x equals -1 into the equation of line AB. Yes, okay, let me copy down what you wrote down. So therefore, y is equal to -3 times -1 plus 7. 7 plus 3, 10. Okay, so this is -1, 10. That's point P. Can? Good. Moving on to part 2. How about part 2? Find the coordinates of the point D on a point on AC. Point D, which is a point that lies on AC, such that AD is to DC is 5:2. Coordinates of the point D on a point on AC. A point on AC. Okay, let's just draw AC first. So there's some point D somewhere on this line, such that AD to DC is 5:2.
Vector.
Here might be a little bit challenging because it lies on the line. It could be here, could be here, could be here.
Oh.
So let's think about it. Which one is impossible? There's only 3 possible possibilities here, in the middle, or on top. Right or not? Point D. If point D is over here, let's say D candidate 1.
CD is more, so that doesn't work.
Yes. Wait, is it correct? Let me think a bit. Yeah, correct. AD should be longer, right? So D1 is out. How about D2? Is that possible?
D2 is can.
Can, maybe the D should be a bit closer to the point C.
Yeah.
Then how about D3? Is that possible? AD versus
Also can.
C. Also can, So that means you know already that the point D should be somewhere sort of below the blue line. Below in a sense that above is there and below is there. Southwest direction. Oh, point D should be somewhere in the southwest direction. So knowing this, vectors? Vectors? AD to DC?
How?
How? Maybe I should draw a bigger picture. Let me just take a screenshot first. And then I zoom in. I need a new page. What was it? AD to DC ratio, what was it again? What's the ratio? 5:2. Okay, let's take a look. How do we do this? So here will be 5. here will be 2. Then that means you have, I can zoom in, gray, sorry?
Yeah.
Yeah, like this all. Okay, good. Then from there you can slowly go work it out. Let's do it together. So if that it was at D3, this means the distance here will be what? 3 to 4. That's 1 unit. So that's one unit representing 7 units, representing 5 units. Does it make sense? I just call it CM. I think it's easier. I just pretend that it's actually CM. Oh, then it's 5 units. Then over here it will be -1 to +1, which is 2 cm, representing how many units?
5 unit.
Not 5. Not 5. Why is it?
7.
7 units. Yes. 7 units. Right, because here is 2, there is 5. Can you see? I zoom in a bit more. Gray. Oh my god. Stop moving. Okay, can. Here is gray, there is gray. This is 2 units, that's 5 units. So total must be 7 units. 2 cm, 7 units. Is it clear?
Isn't it 7 unit?
Where? Which one? Oh, right.
1
You're
cm.
correct. Sorry. Oh my goodness. Wow. You're right. 7. Must be 7. Yes. Then from there, what can we conclude about D3? It must be. Let's figure out. How come both of them are D3? Oh no. That's no good. It should be D2. Let me change it to D2. Yeah, so from there we know D2 must be what coordinates? It must be, let's say we start with -1, add on 2 units out of 7, right? So 2/7 of 2. Then for y coordinate will be 3. You add on 2/7 out of 1. Is that correct? Can hope I didn't see wrongly. Okay, that is D2. But now what if you can type in how many answers are there for D? -3/7 and 2/7. Negative? Oh, okay, fine. Let's now try to work out whether D3 is possible or not. It shouldn't be possible. Let's see. So maybe we draw another diagram. This is D3. I'll draw my triangle, but this time I draw in the opposite direction. So what is the length, the ratio again? AD to DC. AD to DC. So let's just draw a triangle like this, followed by this. Then DC. So where can I draw this? DC here to here. Can? Just instead of drawing it on the bottom right, I draw on the top left. Okay, so it's the same thing. What do we know? The ratio AD to DC is 5:2. So that means we have 5 units here, 2 units here. Okay. If this is total 5 units, this is 2 units, that means that the difference here will be what? You can update the triangle. Maybe we draw here and here instead. Total is 5, right? If it's AD to DC. Then what will be the length here? How many units?
Oh my god.
Or maybe my diagram a bit too messy. I redraw. Okay, never mind. I redraw. Okay, quick one. Quite fast. Okay, here, line like this. Yeah, wait, I need to zoom in on that. So let's say I have something along here, and then I have a point A, which is here. And then I have a point C, which is here. And then I have a point D, which is somewhere in the middle of nowhere here, D3. Then it's question mark, comma, question mark. The two triangles I am drawing currently is this fellow and this fellow. Yeah, maybe sometimes it's worth investing the time to redraw the diagram. It's a lot easier this way. So what we know is AD is to DC is 5 to 2. So AD is over here, 5 units. DC is over there, 2 units. Can you tell me, my question was, this length here, how many units?
3 units.
Neat diagram. Okay, I should have done this from the start. Sorry. Okay, 3 units, yes. 5 minus 2. Okay, so how about this part here? How many units? Also 3 units. Because the ratio will now be will be 5 here, then 2 here. So here is still 3. Okay, so the ratio is basically, okay, I don't need to write so much. Just I like to draw circles to represent my units. Okay, to make it less confusing. So I'm just going to write down 2, 3. Is that okay? Can good. So now how will we obtain our coordinates of D? Maybe we can start off with actually question mark is fine. It should be, sorry, what? 2 is to 1? Why 2 1?
Oh no, as in the CM.
Oh, okay, yeah. Right. Can. This one is 1 cm. Okay, then that means this will be 2/3 of 2 cm. 2/3 of 1 cm. Then you just need to minus off. Yes. Yeah. 3 minus 2/3. Okay, can. Let's double check. Do we get the same answer as the D2? Type in the calculator. So -1 minus 2/3 times 2. This is -7/3. In mixed numbers, this will be -2 and 1/3. Comma 3 minus 2/3. This is 7/3, which is 2 and 1/3. Okay, then how about my D2? Let's calculate this guy, D2. -1 plus 4/7, that's -3/7. Then my 3 plus 2/7 is 23/7, which is the same as 3 and 2/7. Did I get the same answer for both? No. Let's look at the what do you call it? The answer key. They only gave one solution. I think this is the only answer given because they mentioned here a point on AC. They're referring to a line segment AC. They didn't say line AC. They said AC. Do you know the distinguish? How to distinguish? What we have just found is the two possible points. If it was talking about line AC, the entire line, we solved a more complicated question. But the question here is only asking about the line segment AC. So that just means we don't need to care about whatever goes on at the right and on the left. Just focus on the line segment AC can already. Point D is in between there. So only D2. Is that clear? Okay, so that's all we need to know. Point D2. That's the only answer we need. D3 is extra. Still correct, but that's for answering a different question already. The line AD. Okay, this is for, we just need D2, line segment. Okay? Can? Yeah, okay. So this This is all you need, D2. Okay, great, good. 21 done. Moving on. And where are we? 22. Let me mark it first. Here, okay, correct. Then 4/3 x plus 5/2. Okay. Then 6. Okay. Then point D. Where's my point C? Show that OABC is a kite. Not done. And then part D, then never do the rest already. Okay. Yeah, so how do you show it's a kite? Very simple. Special property of kites. Diagonals are perpendicular. But wait, there's another shape that has a diagonal perpendicular. Let me draw a circle. Then let me draw another. Let me mark it center first. Let me draw another. Oh, sorry. Let me draw another circle. Then let me show you. This fella here, from our center to the point on circumference. What is this? This is called a radius. How about this guy? Also called a radius, right? No? Yes? Can Okay, never reply. Set. Okay, center. Then you have circumference there. So what's the length here? What's it called?
What is it called?
Radius, right? Then what's this length here? Also a
radius.
Yes. Now, why do I want to emphasize on that? Because here what we have two circles that I just copy and paste, so they are exactly the same, which means their radius are also exactly the same. So what do you see? What shape is this?
Rhombus.
Rhombus, yes. Okay, good. So now let's take a look. If I draw a line like this, can you tell straight away it's 90 degrees? Yes.
Can I tell straight away? I mean, yeah, sure.
Yes, okay. You can prove it, but no, I'm not gonna prove it here. Yes, it is perpendicular for a rhombus. All four sides are equal. But here kite also got 90 degree, but what's so special? What's so special is that two adjacent sides equal length. Two adjacent sides equal length. But these two lengths here, do you need to be equal? No, I would say that a rhombus is a subset of a kite. Do you get what I mean by that?
Okay.
So it's a special kind of kite, rhombus. So kite is more general. Kite, actually, you just show perpendicular line should be fine already.
All right.
Okay, just need to show these two guys are perpendicular. So can I leave that to you to show? MAO multiplied by MOB. How come got two O's? Oh my god. Wait. Oh, that's a C. Sorry. MAC is perpendicular to MOB. Or their product equal -1. AC perpendicular OB, which implies therefore they are diagonals are perpendicular, which means that this is a kite. Okay, diagonals perpendicular implies it's a kite. Okay. Can
Yeah.
All right, Ken. Then that's part C. Then I'll leave it to you to find out what's the gradient of AC and gradient of OB. Confirm multiply will give you a -1. Now part D. Find the coordinates of E such that OABE is a parallelogram. How? Can it be along the point BC? Do you think? Do you think it's possible? Yeah, probably not. Actually, BC and OA, are they parallel? Not really. Right? Not really. This looks more like a parallelogram, I think. Okay, never mind. With an iPad, I can do this copy and paste. There we go. That's a parallel line. I can also draw a highlighter like this, and then I duplicate it, drag it over. There we go. Then we get our parallelogram. Hey, what do you notice? This point here, it lies along the diagonal, right?
Mm-hmm.
But is that necessary for a parallelogram? In my drawing, it looks like it passes through, but does it always need to pass through? If it passes through, actually, this is a rhombus because you got 90 degrees. In general, parallelogram is just like a stretched rectangle. So like, for example, like this is an extreme case of a parallelogram. Do the diagonals cut each other at 90 degrees? Is that a 90? No lah. It's an obtuse angle more than 90. So definitely not. This is not really a parallelogram. Right? This one is already a rhombus. But oh wait. Oh yeah, no choice. It has to be a rhombus. Because parallelograms adjacent sides, the sides which are side by side each other, they don't have to be equal. However, because this came originally from a kite, these two sides are equal, right? The blue and the gray. So that means that opposite sides of a parallelogram are equal. But because it was a kite, that's why blue and gray are equal. So that means all four sides will now be equal, which means you'll get a special case of a parallelogram, which is a rhombus. Is that okay? So this is not wrong. Parallelogram is okay. It's just that it's a very special kind of parallelogram, like a rhombus. Did you know that? Yeah, it's just a special kind of parallelogram. Okay, okay, good. Did you know that a square is a trapezium? It's a special kind of trapezium. Trapezium is like a family of quadrilaterals, and a square is one of the members of the family. Oh, it's just that it's a little bit square on the side, square on the corners. Not as flexible as a parallelogram, always very rigid, but it is still a trapezium. Trapezium is very welcoming. It allows for squares to be part of the family. Okay? Can Yeah, likewise over here, rhombus is also a part of the family of the parallelograms. Okay, anyways, find the coordinates of E such that OAB is a parallelogram. So it must be somewhere along this diagonal. No choice. Okay, then how? What else do you know about rhombus? Their diagonals will
perpendicular.
Other than that, what else?
Bisect.
Bisect each other. Very good. So that means the distance here to distance here must also be
Equal.
Huh? Can we find the coordinates of this guy here, also known as the midpoint?
Sure.
Can, because we have a point O, 0, 0,
3.
and 12, 6. So what is it again?
6, 3.
6, 3. Okay, so now since it's the midpoint of OB, then this other guy, let's just call this point, what was it again? They call it point E. Then that means that to find the midpoint M, we can also take the midpoint between point E and point A, right? Very good. So that means
plus
that
8 divided by 2 equals 6. And then x equals 4. And then y minus 1 divided by 2 equals to 6.
Okay, equals what?
Equals to 3. So y equals 7.
Yeah, correct. Okay, much better. Good. So now you get the coordinates of E, 4, 7. Just use the midpoint. Okay, this is an important point. Okay, sorry, I didn't mention this, emphasize enough. Just use mid. point when diagonals bisect. So what kind of figures will have diagonals bisecting each other? Kite, rhombus. That's essentially it. Kite and rhombus. This is. How about oh, sorry. Not just that. Actually, there's a lot more. Parallelogram also bisect each other, right? Can you see? How about rectangle? Rectangle also bisect each other. So almost everything bisects each other, except for trapezium. Do they bisect?
No.
Not really, Okay, so trapezium is the odd one out. Okay, almost everything will bisect each other. Yeah, okay, I don't bother listing down the quadrilaterals. You can go and figure out which ones will bisect. Okay, now for part E, find the area of the parallelogram OABE. Can I leave that to you?
Yep, shoelace.
Shoelace, okay, good. Okay, moving on. I just write down a note for you, shoelace. Yep, shoelace formula. Okay, moving on. Got a line, you got a curve, they meet at point AB, find the length. Do you get the answer? Okay, very good. And that's it. Yay, very good. Okay, I think coordinate geometry, you graduate already. Wow, you can do all the questions already. No, it's 10 points. Yeah, you can do most of the questions already. So is it time to move on? Let me think a bit. Max coordinate geometry. What was my plan? Did you do all the homework I asked you already? Homework 2. Okay, Ken. I think it's a bit too repetitive already. You already know everything. It's time to move on. Oh, okay. Let me just see. What's the next topic I want to talk about? Coordinate geometry is done. Oh, right. I forgot to mention the basic graphs. Let me share screen first. This one quite fast. Can you see the PDF? This is from the Stringly.
Yep.
Okay, I'll just share it again. Drop. Yeah. So yeah. So this is the summary. I already sent the file to you on Telegram. I sent it to you a long time ago. But this one, number 3, I forgot to mention. This one, point number 2. Can ignore, not important. Number 1 is the main point. You know how to find equation of circle. Number 3 is the one I want to recap with you. So when you have y equal a times x power n, right? There's a few different different values of n that you should pay attention to. -1, -2, and +2, +3, -half, and +half. And +1/3, -1/3. Here's how the graphs look. When it's -1, you'll get the angry face. If you watch anime or anything, there's this kind of curve that will appear on a person's head when they are angry, something like that. How about part B? When it's power 3, ax cubed is just a cubic curve. It will curve like this. Then the other case, part C, if 2 is +2, ax squared, you'll just get a happy face. But if it's -2, it'll be a over x squared. Can you have a division by 0? Cannot. So that means that there will be this asymptote here. The graph will have will get closer and closer towards x equal to 0, but it will never be at x equal to 0. So you go all the way up. Likewise, it will also go all the way close to x-axis, but never touch. Okay? Because x squared is positive. Then if assuming a is positive, then a positive a divided by a positive x squared will just always be positive. That's why it will always be slightly above the x-axis, similar to the exponential function e power x, or more generally a power x. Good. Next one, part D. You got power half, power -half. Power half is really just square root x. This is how the graph looks. Okay, it curves upwards like that. I hope you can see my mouse.
Yeah.
Upwards. But then for a over square x, you just have to flip it around. Oh. If it gets closer to 0, a over square x just means it must become 1 over the reciprocal of a very small number. 1 over a small will actually make you big. 1 over big will make you small. So that's why they go in opposite direction. Does it make sense?
Yeah.
That's part D. Now moving on to part E, you have 1/3 and -1/3. This one, no choice, memorize one. Ax power 1/3, it looks like this. Similar graph will be tangent inverse. Yeah. Okay, let me just see if I can. Okay. Okay, never mind. Moving on. So number 4, graphs of the form y squared equal to kx, where k is a real number. Okay, so here you realize that it looks very similar to quadratic equation, right? Y equal to x squared. Right? But it's just the other way around. Now the square, it doesn't appear on top of the x, it appears on top of the y. Y squared equal to k times x. So in this case, the graph just gets reflected about the y equal to x. So let me try and sketch it for you. So what I mean is, originally you have this guy. Wow, very, very bad curve. Okay, let me try and sketch it out nicely. Okay, this is y equal to x squared. Very, very badly drawn. But I hope you notice that there's a line of reflection. Can you see that there's a line of reflection here around y equal to x? Yeah, so there are reflections about reflections about the y equal to x. Yeah. Then what about k less than 0? K less than 0 just means you have to go the other direction. Go the other direction. Okay, maybe if I just redraw again. So the curve will look something like this, but then there's a y equal to x. Okay, can you see that there are reflections about this y equal to x? Okay, good. Okay, moving on, clear. Okay, next. Down. Okay, linear law we cover already. Time to move on to trigonometry. Okay. Okay, I have like 10 minutes. Wait, actually, what time do we start? Around like, 10 more minutes. Can I cover trigonometry today? Let's go. Can? No?
Yeah.
Okay. Well, trigonometry, one of the most important topics. You need to, okay, the basic stuff you already know how to do application. Wow, do I have time to start new topic? Or should I just give you a revision on trigo? No time to start new topic. I think I better just give you a revision. Okay, hold on a second. Where is the file? Oh. Okay. Okay, here it is. This is 19 answer trigonometrical ratios. Okay, let's try this. Just a few practice questions. Oh, wait, let me do something. Hold on a second. Oh no. Should I do 19 or 18? I think I'll do 19. Okay, so let's try this question. You have a following diagram in question 1. Angle ABC and angle DBE. They are what? They are what angles? 90 degrees. So I hope you can see the two hidden triangles here. Yes. Oh, then you know DE is 17, and you know that DB is 8. Expressed as a fraction in the lowest terms, the value of sine, whatever, tangent, whatever. So I hope you remember tua, ka, so. What does it stand for? Let's do a quick example. If this here is theta, that's a 90. This is 3, this is 4, this is 5. Tangent theta is?
Opposite over adjacent. 4/3.
Cosine is?
3/5.
Sine is?
4/5.
Okay, what is sine theta divided by cosine theta?
Is it tangent theta?
Yes, exactly. Or if you just fill in the blank, you get 4/5 divided by 3/5. 5 will cancel away, 4/3, which is tangent theta. Okay? Can
Okay.
Good. So now let's answer the question. Sine of angle DEB. Now take note, they never ask you sine inverse, find the angle. Just find the sine. DEB is where? DEB, this angle here. So sine is what? Opposite over hypotenuse, so it's?
8/17.
Okay, good. So 8/17. How about tangent BDE?
Opposite. It would be divided by 8.
BE divided by 8. But wait, we don't know what is BE, huh? Never mind, can just write down first. Because it's a 2-mark question, you need to solve for BE first. How do you find BE? Let's take a look.
Square root 17
Ah.
square minus 8 square.
Okay, very good. So this is 15. Then what you realize is that in this kind of questions, that's in Emacs where you have a lot of problem solving, you will no longer face such questions in Amax. Not so much. The questions are more of teaching you a standard step-by-step procedure to solve equations of a certain format. Okay? The setting up of the equation, that's like engineering or physics. But once you have the equation, how do you solve the equation? That is usually the emphasis of the AMAX syllabus. So this one is just a warm-up only. You won't be seeing such simple, I mean, you won't be seeing such problem-solving questions so much anymore in AMAX. Okay? Let's just finish up one more. Part B, given the angle triangle ADF is an isosceles triangle, here, like same length, calculate the value of angle AFD. Leave your answer to 1 dp. How? Can we find out what is this angle first? Can. How?
Tangent inverse 15/8.
15/8. Oh, can also. Yep. Then you get some angle. But wait, what is this angle now? You'll just be pi, or sorry, 180 degrees minus away. Okay, we don't talk about pi later. Eventually, I'll have to talk about pi. This is 61.927 degrees, so 180 minus, right? Then you get a 118.07 degrees. Yeah, 0.072 degrees. Okay, then in this case, this is the angle here. But what kind of triangle is this? Isosceles triangle, two sides equal. So what do you know about these two angles at the side? They are equal. How do you find the angle?
180. Okay, 61.927 divided by 2.
Very good. Here you should know another trick. The angle here and the angle here add together will give you the angle at the outside. This is called exterior angle equals to sum of interior opposite angles. Do you know this?
Yeah.
2 light blue will give you dark blue. Okay, can. Then yeah, just divide by 2 and you get your final answer, which is 30.96. 30.96. 61.927 divided by 2. 30.963 degrees. Round off, you get 31.0, 1 dp. Do you remember your sine rule and cosine rule?
No.
No. Okay.
Wait,
It's not
as
in
in
this.
like, do I get like the formula sheet thingy?
Do you get formula sheet? I guess. Let me think. You are training for A max or yes, you're given that formula. Yes.
Then I think I know how to do.
Okay, but try to memorize it. Actually, be useful. Okay, can that is just a warm up. Nah, I'm not gonna go through the rest. Let's start on some new topics related. So I'm gonna start off by giving you just the definition. What is definition? Definition means you just memorize. It is the way it is. You can go and argue with philosophers why the definition is the way it is. But here, sine, cosine, sine theta. Okay, I'm gonna draw the triangle first, right angle triangle. It's just Picasso, okay. I just want to recap. Here is theta, here's a right angle triangle. If this is ABC, sine of theta will be what? B over C. Cosine of theta is what? Adjacent over hypotenuse. Then tangent of theta is what? Opposite over adjacent. So B over A. Picasso. Now, there's a special properties. Tangent theta is the same as sine theta over cosine theta. Okay? Can? This applies for the theta being in between 0 degrees and 90 degrees. But what happens when it's more than that? What happens when it's at the extreme angle, 0 degrees, 90 degrees, 0, 90, 180, 270, 360 degrees? What happens when it goes beyond 90 to some obtuse angle or some reflex angle, more than 180, less than 270, or maybe even a Pac-Man?
I mean, you're drawing a lot of this thing.
Yes. Correct. So the reason why we went through all the topics on surds as well as all the topics on coordinate geometry is because the definition of trigonometry for angles beyond 90 degrees requires coordinate geometry. You learned before?
No, I'm just trying to see what you're doing.
Yeah. Sorry, say again?
No, I'm just trying to see what you're doing.
Yeah. Okay. So this guy, like you can have an angle here, or you could have, okay, let me just draw a ribbon. You can have an angle here, you can have an angle here, you could have an angle here. Oops, no, I want to go beyond a bit. Or you could have an angle here all the way. What is the sine of all those different angles? Cosine, tangent. In Amax, we can give you an answer. In Emax, there wasn't really an answer. Obtuse angle have. Okay, that's what I'm gonna introduce now. Definition extended. Extension. Beyond Emax. So to angles that are beyond 0 and 90. So what I need you to draw for me, if you're taking notes or anything, is first a unit circle. What's a unit circle? A unit circle is a circle centered at 0 and the radius being equal to 1. Okay? Draw that. Can? Good. Then we carry on. So now, coordinate geometry, that's why you go through equation of circle first before we talk about this. So now, I hope you can see that in order to form any angle, you always start from one point, draw two lines, right? Correct or not? Yes, So let's say you draw this line. Do you need to rush off? Or sleep?
No.
No, Okay, I can continue. It's fine. This angle, this line, and this line, can you see that it forms an angle?
Okay.
Like you can imagine this is like the sun. The sun rises from the west, or is it the east? from the east.
Okay.
Okay, so it goes from the east towards the west. Okay, if you've been staring at the sun somehow. So the history behind this is ancient people they look at the sun, then they think, wow, the sun moves from the east to west. Maybe I can model it. Sun, the movement of the sun. That's why the angles will always start from the horizon here, pointing towards the east, and it slowly rotate in the direction of the sun. Okay, trigonometry is built from observations of the movement of the sun. Okay, and you want to or more generally the movement of celestial objects, all the planets in the different outer space. Okay, you can use trigonometry to figure out their positions. But let's just look at this basic example. This is radius of 1, right? Over here. So hypotenuse, can you see a hidden right angle triangle here? Is 1. Agree? Or vector method we've been doing so far. I use my same color coding, green color, purple color. I always use this 2 color. Can you tell me what is the length over here? Tua Castle. And the length for that. One of the options are which one?
Use this. Use sine.
So let's take a look. What is sine of theta? Sine is opposite over hypotenuse. Wait, isn't that just the purple length? Divided by what?
Divided by 1.
So it's just equal to the purple length. Okay, that's interesting. How about the floor here? Imagine you have a torchlight shining on top. Then you cast a shadow. This is like a shadow. What's this shadow length here? Not sine, then must be what?
Cosine.
Exactly, let's check out. Cosine theta equals to adjacent divided by hypotenuse 1. Isn't that just adjacent? Isn't that just a green length?
Yeah.
So equals to green. Okay, the purpose of why I have set the radius to 1 is so that when I divide by 1, I can just get my adjacent length. Divide by 1, I can get my what do you call it? Get my purple length. So yeah, anyways, color. All right. I should just write down OPP. Okay, so very good. What we have identified is that the perpendicular is the sine of theta. The adjacent there is cosine of theta. Agree so far? Okay, so can you tell me now, in terms of x and y axis, x and y coordinates, what's this point here? Cosine theta, the adjacent adjacent number. Do you agree that it's actually just
adjacent opposite?
Opposite, right?
Yeah.
More generally, actually, if this was just a letter R, this would be R times adjacent, R times opposite. Okay, you have to divide by R here. Then if you want to make opposite a subject, you have to times the R over. If this is R here, you have to times the R over. So adjacent equal to R cos theta and R sin theta. But here, we simplify because you're just beginning. I'll just change the R to 1, make things simple. So 1 times adjacent, 1 times opposite. But remember the general formula, it's R times R times. Oh wait, sorry, I forgot to explain yet. Adjacent, of course, by now you know it's cosine theta. Opposite is sine theta. Agree so far? Very good. So the coordinates of a point here, where you have a person starting from the horizon, he look at the movement of the sun by a certain angle theta. He ends up at a certain point here, and the coordinates of that point is cosine theta, sine theta. That is for an acute angle so far. But now we're going to generalize this idea. You realize that cosine theta is always x coordinate of this point here, of this line here. I don't know what's the name of this line. Let's just call it a satay stick. The satay stick. Actually, it looks like a drumstick. A drummer, a bit. The drummer, they use it to bang the drum or something. Okay. Then here, x coordinate is always cosine, y coordinate is always sine. Can we generalize this further? So what I mean is, now if I just copy and paste this diagram, but now I go look at a different scenario. what if my angle here changes? Oh no, let me erase everything. Forget it, I'll just erase everything. This right? Yeah, okay. So let's say that now I have a different scenario. What if I have my line over here? So maybe it's already 12 p.m. The sun is here. Maybe this one is already 2 p.m. 2 p.m. So you get this angle here, which is an obtuse angle. In this case, what will sine, cosine, and tangent be? Well, it makes sense that if we have Tuakaso for our acute angle, right? This is acute, right? It's a 90. It will make sense that we should still stick to the same definition. Here, I'm actually building up to what's called a definition extension. Basically, you just need to memorize the definition, but I want to show you the intuition behind it. So here is the quadrant. Oh, sorry, I shouldn't introduce quadrant. This is the obtuse angle, right? You know what's an obtuse angle? More than 90, less than 180. Can you notice that there's this angle here? It's acute. We usually denote this with a letter alpha. Alpha here is referring to an acute angle, but we don't usually call it acute angle. We call it reference angle or basic angle. I like to call it basic angle because that's what I was taught. But I realized that there were two different names. Reference angle or basic angle. Okay, I'll be referring to basic angle. Yeah, so that's called the basic angle. It's just beside the obtuse. Later on, you'll see other versions of the basic angle. Here is just intro only. So I hope you also notice that there's another right angled triangle. Let me see my color coding. Okay. Here and here along with the hypotenuse, right? Let's assume the radius here is 1. So what you realize is that over here, you would think that it should be maybe cosine alpha, sine alpha, right? Can but then there's a problem.
Negative.
Whenever yes, which one should be negative, x or y?
X.
X should be negative, right? Because it's towards the left of the y-axis. So that means that you actually need to introduce an extra negative sign in front of cosine alpha. Is that clear? But this is with reference, this point here is formed by taking this line here. Some persons, he stare at the horizon, the sun as it rises from the horizon, all the way from the 6 a.m. until 2 p.m. Then he looks at the movement and he realizes it sweeps out theta degrees. So so by definition, this coordinates, right, would actually just be equal to cosine theta, sine theta. Is that okay? Just like the pattern from before. X coordinate cosine, y coordinate is sine. Why don't we just stick to the same pattern? Okay, just stick to it. Move a bit more, but the cosine and the sine still remains in the x and y coordinate. Okay? Can?
Okay.
But then, you realize cosine theta is now negative cos alpha. Sine theta is sine alpha. That's a bit funny. But either ways, it will still be the coordinates of that point. So now that we have covered an angle that is more than 90 and less than 180, let's go for the third version. Let's go for the third version. What do you think it will be? I think it's kind of obvious. I'm just going to increase the angle a bit more. Well, if we went beyond 90 degrees already, why not just keep going? Let's go all the way to here. Then we sweep out our angle all the way. Maybe this is 200, maybe this is 300 degrees or something. 90, 180, 270 degrees, 360 degrees. Okay? Then in that case, what's the coordinates again? It will be cosine theta, sine theta by definition. But what does it mean to take cosine of a theta when it's more than 180, less than 270? You haven't learned this, right? So that's when I'll build up to it. So I want you to compare and contrast. Can you tell me, where do you think is my little fish? This is alpha, by the way. A Greek letter. Where do you think is my alpha? Can you shade in for me? Very good. You got the intuition. So it's exactly over here. My little fish my alpha, my reference angle. Because I want to link throwback to the basic definition of Picasso in acute angles. So whenever I have angles that are more than the acute angles, I have to reference back to my reference angle. Reference back to my reference angle. Okay? Yeah. So you have to draw that little fish over there, alpha. And you have these two horizontal. So I hope you realize that this will just be equal to what? Cosine alpha sine alpha lah, huh? But a problem. Yes, you need an extra minus sign for both of them, huh? Okay, because this is now in a negative region for x and y. Then finally, the last one, actually not the last one, we still got to deal with some problems with the extreme cases when it's 90, 180, 270, 360. Okay, wait. Continue. Let me just recycle this so I don't need to keep writing. And you can see the repeating pattern. So, oh, I hit my detail. Now I want finally, let me just try to make it look nice somewhere along here. This is the new point. You have a new angle, this huge angle. This is more than 270 but less than 360. Again, by definition, this point here will have a x and y coordinate. We define it to be cosine theta, comma sine theta. But now can you see where's my little fish? Alpha? Where? Straight in. Wrong.
Oh, like here.
Yes, correct. Okay. Sorry, but yes, that is actually an acute angle, right? But unfortunately, that's not the definition. That's not the definition. In our definition, we need our alpha to be over here. Okay? Your little fish. Okay? So now you get cosine alpha, sine alpha, huh? Which means you get your adjacent here and the opposite here, right? Right? That's why you need the cosine, the alpha to be there. Actually, let me just show my color coding. Check my color coding again. I want opposite length to be purple, adjacent length to be green. Oh, then in this case, can you tell me what would it be?
Positive x minus y.
Yes, exactly. Right, because your quadrant, this is what we call, oh, it's time to introduce the names already. This is what we call quadrant 4, where it's positive x and negative y. So that's why positive here, negative there. Let me just label the rest. This will be what we call quadrant 3, quadrant 2, and quadrant 1. Okay? Q1, Q2, Q3, Q4. All right. So now that you know this very long-winded way of introducing it, I'll teach you the shorter way now. Okay, I'll teach you the shorter way. Go back to the first one. Cosine theta and sine theta. This theta is really just alpha. So it's equals to cosine alpha, sine alpha. The trick here is to summarize everything that we have drawn. Let me just, let me try and make it look nice. Okay, this is an interesting topic. I like the introduction. It's very, very weird. Let me try and combine them all into one page so it's easier. Yeah, okay, and then the third one. Okay, roughly like this, I guess. Okay, and then the fourth one, wait. Paste it here, shrink it. Yeah. 不剪掉。Copy, paste it, shrink it down. Oh my goodness. Okay. Move it over here. Okay. So now we are combining it all four onto one page. So this, what I'm trying to bring up here is that you realize that actually here there's only which guy is positive? Cosine and sine positive, right? How about tangent? Now let's say what is tangent of theta? I hope you remember the special identity I told you at the beginning. Right over here, special property, tangent theta is sine theta over cosine, right? Or opposite of adjacent. We're just gonna use sine over cosine. It's a standard formula. So over here, tangent theta will be, okay, I don't use red color. Use black. It is really just sine over cosine. You also realize is that they will both be positive and positive, right? So that means that all trigo ratios are sine, cosine, and tangent are all positive. We will write down an A over here. Okay, A for all positive. How about this case? What is the tangent of theta in this case? Tangent of theta will be sine theta over cosine theta, which we realize is sine alpha over negative cos alpha, right? Which is negative of tangent alpha. Okay, sine alpha divided by cosine alpha is just tangent alpha, but you have an extra minus sign. Tangent alpha is tangent of an acute angle. Alpha is like this basic angle, acute angle. Then you have a negative in front. So that means that this will be less than 0. Does it make sense? I'm using symbols. Alpha can be any angle, let's say 30 degrees. Oh, so what I'm saying is that, and this one could be, if it's 30, then this will be, for example, 150 degrees. This will be 30 degrees. So what I'm saying is cosine of 150 degrees, comma, sine of 150 degrees is equivalent to cosine of 30 degrees, but you have a minus sign. Sine of 30 degrees, but you have no minus sign, just positive. And for tangent alpha, it will be tangent 30 degrees. Tangent of 150 degrees will be negative of tangent 30 degrees. Okay? Can? Good. So who is the only guy that's positive here? Sine 150, cosine 150 versus tangent 150. Who's the only guy that's positive here?
The sine 30.
Only the sine 150, which is equivalent to sine of 30 degrees, is positive. That means only sine is positive. S. Okay, we put down an S. And then for the third one, you can check it on your own.
Tangent.
Only tangent is positive. And for the last guy, only cosine is positive. So the general rule that is, this is a very long-winded introduction. The usual way to introduce it is just, okay, class of one person. Here is circle ASTC. All science teachers crazy. Or add sugar to coffee. Okay? Add sugar to coffee. Memorize. Sugar to coffee. This is a rule that tells you that whenever you take a sine, cosine, or tangent of angles that are in these 4 quadrants, you'll get different signs. Okay, so maybe just I don't know how to assign you homework. I haven't gone through enough topic. Let's say that we just do a quick experiment. So ASTC, maybe I write it a bit smaller. ASTC. Let's try to do an experiment. If theta equals 30 degrees, find out what is sine theta, cosine theta, and tangent theta on a calculator. If theta equals to 150 degrees, find out what is sine, cosine, tangent. If theta equals to let me think, 180 plus 30 is 210 degrees, find out what is sine, cosine, tangent. Likewise for the other case, if it's 330 degrees, find out what is sine, cosine, and tangent. Oh. Okay, does it make sense, the instructions?
Yeah.
So should I go through now or should I assign as homework?
Anything.
I think it's better if I go through now. Okay, basically, do not trust the calculator when you're trying to calculate this. What you need to do is to figure out the associated alpha, the little fish. How do you do that? How do you identify your little fish? First, you must draw your ribbon diagram. Okay, maybe should I just squeeze them all in one diagram? Yes, I will do that. Ribbon diagram. Ribbon tells you where to draw your alpha. Right? Alpha here, 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 or here. Is it very messy? Can you see clearly?
Yeah.
Okay, I think I better make my ASTC far away. Okay, not nice. Let me try and make it look nice. Yeah, okay. Then my alpha will be here, 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 and here. Oh, so what do I mean? So what is my current alpha if it's 150 degrees? 150 degrees means start from positive, must always start from positive x-axis, rotate anti-clockwise. The movement of the sun. That's your 150, then what's your alpha?
30.
30. Alpha here is just 30. How about 210? 210 means you reach here, and it happens to also be 30. It's a coincidence, okay? It's a coincidence. Blend it, okay. 330 degrees, then where's the alpha? Here, right? So it's 360 minus 330, must be 30 degrees. Then from there, you use the ASTC rule. So what is sine theta? It's just sine alpha, which is sine of 30. Always go back to your acute angle. Oh, sine, cosine, tangent. Okay? Okay, wait, I need black color. Okay, let's make this black. All right. Then this sign is plus, plus, plus. Why? Because A stands for all positive. Plus, plus, plus. After you convert theta into the alpha. So now we're going to do the same thing, but for the 150 degrees. For the 150 degrees, it will be the same thing. But the problem is that now you only have S being positive. So that means only S will get to have the plus sign. The rest will be what sign? Minus sign. Okay? Is that clear?
Yeah.
Whenever cosine 30 is and tangent 30, you can use a calculator to get the value. You'll figure out how to calculate the exact value in a later class. So how about here? T means what?
Tangent.
Tangent is positive. So what should be the sign?
Rest negative.
Tangent positive, the rest negative. How about cosine?
Cosine positive, the rest.
Very good. So like this. Clear? Whatever the number is, sine 30, you can use a calculator, 0 point whatever. Actually, it's half. Yeah. Okay. Can good. ASTC covered, alpha reference angle covered, and the evaluation of sine, cosine, tangent of the 4 extreme angles in the different quadrants. Not extreme, 4 quadrant angles covered. Haven't covered the extreme angles. So now let's go back to the definition at the beginning. The definition extension is basically telling you that you draw a unit circle, then you have a line on the positive x-axis, you have a line that where you rotate anti-clockwise by a certain angle, and you intersect a point on the circumference of the circle. The coordinates of that point, x, y, will become cosine theta, sine theta by definition.
Okay.
Is that okay? Then now let's consider what happens for the 4 extreme cases where it's 0 degrees, 180 degrees, 270, and 360. What do you think will be the sine and cosine of those values? Tell me what the coordinates of these 4 points are for a unit circle. This guy, 1, 0. This guy?
0, 1.
Other guy?
Negative 1, 0.
Last one?
0, negative 1.
Okay, so these are the xy coordinates of all of them. But wait, if you look at this x coordinate, you must remember it's cosine theta, sine theta, right? But what's the angle? Cosine what? Sine what? This line. There is no angle, right? Usually you turn a bit, then you have some angle.
Yeah.
But here is no angle, so it's really just 0 degrees. So cosine 0 degrees is 1, sine 0 degrees is 0. Does it make sense? It's a definition. How about this guy here? What's the angle that you're making? From the positive x-axis, you rotate anti-clockwise. What's the angle? Until you reach here. What angle is this?
90.
90 degrees. So over here must be cosine 90 degrees, then sine 90 degrees. Make sense?
Hmm.
Then how about this guy? What do you think is -1? Cosine of what?
Cosine of 180.
Exactly. Is -1. Then other guy is sine of
180.
Then what about this one? 0. This is cos. Okay, don't tell. Tell me what is it.
Cosine 270.
Okay. And the other guy is
Sine 270.
very good. Okay, so now of course, what if you want, how about let's say cosine of 360 degrees? What's 360 degrees? Very simple. I follow the procedure.
1.
Yes, you realize, it's the same as 0, right? Because you just turn one full circle, you go back. Also, that means that this is actually just the same as cosine of 0 degrees, which is 1. How about, let's say I want now cosine of 720 degrees.
1.
It'll still be 1 because 720 is 360, and you make another round, 720. Then what you realize is that, you just need to keep on adding angles, then you can get the same result. But now what happens if I want cosine of -360 degrees? What would that be?
1.
I haven't introduced yet, but I think you can roughly get the idea. When it's positive angle, you go anti-clockwise one round, 360. Then if it's negative angle, what direction do you go?
Anti-clock. Clockwise. Clockwise.
Clockwise, yes, correct. The normal direction is the sun rising from the east towards the west, so anti-clockwise. But now we are having negative angle, so we turn clockwise instead. Make sense or not? So interesting. Now angles have a direction. So this is actually just cosine of 0 degrees, which is 1. Okay. Now can you figure out what is cosine of -30 degrees? Draw a picture. Where will it end up? You rotate this guy anti-clockwise or clockwise?
Clockwise.
So can you draw the resulting line? The resulting line. Correct. This is the line that results. This will be your -30 degrees. Then the intersection with the circumference there, that as a coordinates, that is your cosine of -30, comma sine of -30. Let me try and write it nicely. Cosine of -30, comma sine of -30. Is that okay? Can now? But then where's your alpha?
Sure.
Wrong. Ribbon diagram. Draw the ribbon diagram and you can recall where's your alpha already. Alpha, 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 alpha.
Okay.
So where's the alpha?
Here.
Yes, correct. So that is your alpha at the corner. When it's an angle over here, the alpha is over there. So now that you have identified the alpha, can you tell me what is the angle alpha? Alpha is always a positive acute angle. Less than 90, more than 0. So alpha is 30 degrees. So that means that this guy is actually just cosine of 30 degrees, right? But plus or minus? C. C means cosine is positive, so plus sign over here. What about sine?
Minus
this will just be
sign.
sine of 30 degrees, but with an extra minus. Exactly. Okay, that's how you use it. Using the graph. So now you are ready. Okay. I've taught enough so that you can do one exercise already. Yes, very good. Okay, that's all for today. I have no time for examples. You can try on your own.
Okay.
Go through next lesson. Okay, intro to sine, cosine, tangent of all the different angles. Also take note, you might have heard of this sine curve and cosine curve. Very famous. Sine curve, cosine curve. You will need to learn this. It is based on the unit circle. I'll send you a link later with a GIF. You try to make sense of whatever is going on. Okay, that's all for today. Bye-bye.
Okay, thanks.
Okay.
I don't know how. Yeah.
Okay. Bye-bye, that's all.
Bye.
All right.